Hello everyone, welcome to the Faded Insights. Today in this video I'm going to explain you about the concept of capacitor. So in this we are going to discuss about how the capacitor charges, what is steady state, what is transient, why the capacitor blocks DC and some other things. So here is the thing I'm gonna take you through. In this manner we'll discuss the concepts. First I'll walk you through the basics, then it is followed by the concept of capacitor. Here guys, the basics play a very vital role in understanding the concept of capacitor, so please stick to the basics first. And then we'll go to the concept of capacitor, where we'll be discussing the things I mentioned earlier, and it is followed by the waveform analysis, and the final one is the practical proof. Here in this thing I'm going to show you how the capacitor charges with the help of an LED. This will be very beautiful guys, how it charges. This thing will be very beautiful. So I need you to stick to the entire video from the very beginning to the end, because if you are here to learn really about the capacitor, do stick to the video from the beginning to the end. So let's go start with the basics first. So in the basics we'll start with the current first. So the rate of change of negative charges or the movement of negative charges is nothing but the current, right? There are certain conditions in circuit theory for the flow of the current. One of the conditions is the circuit must be closed. Look at this. Here the circuit is closed, otherwise the current won't flow. If the circuit is open, then the current is zero in the circuit. But in case if we connect a capacitor in a circuit, there will be current. How that will happen? Because look at here. Assume these are two plates of the capacitor. These things are two plates of the capacitor. In between these two plates, there will be an insulator blocking the path for the electrons to flow. So here the electrons won't flow. If I connect it like this, the electrons won't flow from this plate to this plate, from here to here. So this is an open circuit, right? But how the current actually flows when the capacitor is connected in a circuit? That is why I am mentioning here. The current is the rate of change of charge, negative charges, the rate of change, or the movement of negative charge carriers. So this will be clear when we delve into the concept of capacitor. You have to understand the movement of negative charge carriers. I am stressing on that because we need just the movement of negative charges. There is no need to be the circuit to be closed, right? That is one thing you have to keep in mind. And one more thing is that, look at this. Here I just want to tell you some more things. Yeah. If you want to calculate the value of I current in this circuit, this is a closed circuit, right? Because these two are grounded. This is a closed circuit. And now I need to calculate the value of current by changing this V2. This is a variable. I'm changing this V2, and we are going to see what are the effects by changing this V2. So I'm writing this V2 as 0 volts first. 0 volts. Now you can see the current. We know that current I is equal to V over R from Ohm's law. So this V, what I am mentioning, is nothing but the potential difference between these 2 points. These 2 points, right? So 9 minus V2 is 0. 9 minus 0 over 2. This R is 2 ohms, right? 9 minus 0 over 2 is nothing but 4.5 amperes. 4.5 amperes actually. So I'm going to take this V2 to 2 volts. You can observe this. 9 minus 2, 7 over 2, that is 3.5 amperes. And now I'm changing this V2 to 5 volts. 9 minus 5 is 4. 4 over 2 is nothing but 2 amperes. You can observe here, by changing this potential, the current also changing. It is varying and it is decreasing. So it is decreasing because we are actually reducing the gap between this V1 and V2, right? We are actually reducing the potential difference between V1 and V2, and so the current decreases. So now I'm going to take another value like 7 volts. I'm reducing this further. 9 minus 7 over 2. That is actually 2 over 2. That is 1 ampere. Look how it reduces. If I'm going to take 9 volts here, which is V1 and V2 are equal, 9 volts. This is very important case. If I take 9 volts over here in this V2, yeah, this is 9 volts and this is also 9 volts. Now 9 minus 9 over 2 is nothing but 0 over 2, which will be 0 amperes. Look at this. So when I reduce the potential between these two, the current actually decreases. When I bring this V1, this V2 to V1, then the current, there will be no current flowing in the circuit, because for the flow of current there must be potential difference between the 2 points, otherwise the current won't flow. Because here look at this, when we place this 9 volt here and here there is 9 volts, there will be no potential difference between these 2 points, hence there will be no current. So for the flow of current there must be the potential difference is required, right? This thing you have to keep in mind, and you have to observe this table by varying V2 how the currents is also varying, right guys? So guys, one more thing we need to discuss is atoms. The atom is always neutral, right? So the positive charge is equal to the negative charges. But in some metals, if we apply sufficient amount of force or energy to this atom, we can actually bring out the electrons which are in the valence part of this atom out of the atom. For example, by applying sufficient force to this atom, we can bring this valence electron outside of the atom. As a result, it will become positive ion. So this you have to keep in mind. So another thing is when there is positive and negative charges at some possible distance, there will be some field pointing towards positive, from positive to negative charge. That is nothing but the electric field. In case of, we know that like poles repel each other, unlike poles attract each other. In case of magnetism, from north, if you take north and south, there will be field from north to south, right? So in the same way, in case of this electronics, we have from positive charge and from positive charge to negative charge, there will be electric field pointing starting from the positive charge. This what I have to mention, because these all the things are collectively going to play a vital role in the concept of capacitor. So guys, now we will discuss the concept of capacitor. So look at here, these are two parallel plates. Of course, the capacitor is constructed by using two parallel plates. So these are conductive plates, okay? So in conductor, we know that there will be atoms present, and these atoms are neutral in nature initially. So here you can observe these are the atoms. Pardon me, I am not good at drawing. So these are the atoms, and you can see the valence electrons circling outside the atom. I placed it there. So these two plates have some amount of atoms, and they are separated by a medium. This gap here, this is nothing but the dielectric, some kind of insulating medium. So what happens here is that when electrons comes here, the electrons cannot jump over from this place to this place. That is not possible. This is preventing this gap is preventing the electrons, or this dielectric is preventing the electrons from going from this place to this place. That is nothing but, we can say technically it is an open circuit, right? But the current cannot flow in the open circuit, right? But here we can observe how the current flows. As I mentioned earlier, we'll see how the current flows here, because this is the open circuit. So now I just connected this capacitor to this 9 volt source voltage, or this 9 volt voltage, and in parallel, in series with a resistor over here, and I'm going to measure the value of current. I is nothing but 9 minus Vc. This is the voltage across the capacitor, Vc over 2. So guys, I just want to tell you one thing. This Vc is a function of time, but I am not going to the complex equations. I'm just assuming some values for the voltage over here when we'll go to this concept, and we will theoretically we are assuming some values and calculating the value of the current. Okay, so now look at this. These are initially neutral, so there will be no force of attraction, there will be no force of repulsion, there will be no electric field, nothing over here. Okay, when I connect this when I make this on, because of this 9 volt source, this energy is pulling up the electrons, staying in the valence place of the atom. Because of this force, they will come out. We already discussed this earlier. These electrons will come out, and as the electrons move out of the atom, it will become positive ion. So this electron will travel through this path, and it will be pushed into the another plate. The electron that is removed here, it will be pushed by this voltage source into another plate. So now what happens is that there is some positive charge and there is some negative charge, right? Initially they are neutral, but now it will be it become positive, and now it becomes negative. So that means there is some additional charges here, that is positive and negative. So if there is a charge imbalance, then we already discussed it, there will be some field present between these. That is nothing but the electric field. Okay, this is electric field between these two plates. Okay, so these electrons cannot jump from here to here. So this is open circuit, right? So here comes the concept of current. So from the electrons coming from here to this, traveling from here to here, I mean moving from here to here, this point of time is nothing but the current. As I said earlier, the movement of electrons, we need just the movement of electrons from here to here. So from here to here, there is movement of electron, or the rate of change of electron is there. So that is why the current is flowing in the circuit. That thing you have to remember. So yeah, positive and negative, and this electron is forced here. So this is accumulated in this plate. Now what happens? This electron is forced here. We just deliberately put it here, but it tends to balance. That means it is having some potential, but this 9 volt source is preventing it from going to the back position, I mean to the initial position, to balance. So this is having now some potential. If I remove this 9 volt source, this will go and balance, it will balance out. That is the nature. But this guy is preventing from the electron. This guy is preventing the electron from going back to this original position. Okay, I'm sorry guys, just if something flow mistake is there, pardon me. Yeah, so now what happens, as there is a potential difference between these two, I'm using this some potential 2 volts somewhat, because this is having some potential now. So I'm assuming this as 2 volts. Now I'm going to calculate the current. This current is nothing but 9, this here, because it is 0 volts. So here it will come 9 volts, and this is Vc, here it will comes Vc. Between these two, 9 minus 2 is nothing but 7 over 2. That is nothing but, if I assume Vc as 2 volts, then the current will be 3.5 amperes. Okay. So look at this, the electron is, one more thing is, the electron is traveling from here to here, this plate to this plate, and That is the reason I am considering the current direction opposite to the direction of the electron flows. Okay, that is the convention we are following from the beginning to avoid some negative calculations. So the current always flows in the opposite direction to the electron flow direction. This plays very crucial role in case of discharging of a capacitor. Now I'm going to take another atom, so I'm going to take another electron. It will comes here, and it is as usual it is picked by this, and it will be accumulated in this plate. So as a result there will be more negative charge, and here it will become positive ion. So there will be the electric field will also changes, because we are changing here the charge imbalance changes, the electric field also changes here. Look at this. So as there is two electrons here, the voltage again increases, because there is having much potential because of these two. So now I am increasing this voltage across the capacitor to some 5 volts. So now I am going to calculate the current again. 9 minus 5 over 2, that is 4 over 2. If 4 over 2 is nothing but 2 amperes. So if I take BC is 5 volts, my currents changes to 2 amperes, right? Again this, guys, one more thing, this process happens in fraction of time depending upon the resistance we use and other elements. I'm just, for understanding purposes, I'm just saying that I'm just taking this atom will go, you can understand that, right? So now I'm going to this battery now pulls this electron from this atom. It will become positive ion, and it will be accumulated in this side, and again the charge changes. It will become more positive, this plate will become more positive, this plate will become more negative, so that there will be change in the electric field. You can observe here there will be changing electric field, and because of these the potential increases. So that means I'm changing the voltage across the capacitor to what, let's say a 9 volts. So this is 9 volts now. Now you can observe here 9 minus 9 is nothing but 0 over 2. If I take VC as 9 volts, and the current will become 0. Here observe this carefully. Here the current is 0. That means you can say this. Here I'm taking this reached to 9 volts. That means this capacitor is charged to the source voltage. This capacitor is charged to the source voltage 9 volts. So then there will be no potential between these 2 points. So the current is 0. Of course there are some remaining electrons are there, but what happens is this. What happens here is this capacitor charges to 9 volts, and there will be no potential difference between these 2 points. So the current will be 0. This is the condition of the steady state. So here there will be no current further. The current is 0 further. So this is the case we are saying that the capacitor blocks DC. That is, when capacitor is charged to the source voltage, then we are saying that the capacitor blocks DC. Otherwise, before that, look at here these values. Look at these values. These values 3.5 and 2 amperes. This is nothing but the transient phase of the capacitor. This is nothing but the transient phase of the capacitor. And this guy, when it reached to 9 volts, this VC reached to source voltage, then it is nothing but the steady state. So when the capacitor blocks DC is that when the capacitor charges to the source voltage, then only when we can say that it blocks DC, or it reaches steady state. It blocks DC over here. This is the condition. You have to mention that when the capacitor charges to the source voltage, then only it blocks DC. This is the thing you have to understand. Here one more thing is, there are 3 variables in this case. The electric field, you can see by changing this by the electron moving from this plate to this plate, the electric field is changing. You can observe this. and you can find this the change of electric field creating the magnetic field in Maxwell equations. You can observe this thing. Okay, there are three variables: the electric field is changing, the current is changing, as well as the voltage is changing. This you have to, these are the three variables you have to understand this concept of the capacitor. So now what I'm going to do is practically, I just said the practical thing, right? So now I'm going to connect a LED over here. So LED over here. Let's assume that this is initially, these are not positive charges. LED over here. LED bulb, actually, LED bulb. So now what happens is, initially when this electron comes from here to here, initially we are going to the initial position where everything is fine. The electrons are intact with these atoms in the upper plate. So I am connecting LED here. These atoms will be pulled by this. You can see the current will flow through this. The current is 3.5 amperes, and again the current reduces. So that means as the current reduces, the LED will fade away. The LED will fade away. When the current becomes zero, the LED will gets off. It won't glow. This LED won't glow. So based on this thing, the LED fades away. That is what I am going to show you in case of in the practical experimentation. So now we'll see this the waveforms. We'll see some waveforms, analyze them. So guys, now we are going to look at the waveforms. So these are the observations. I hope you can see that we discussed earlier. So now I'm going to draw the current waveform, this in the circuit. Initially it is 3.5 amperes. Initially it is starting from here. This is 3.5 amperes, and it jumps to 2 amperes. So at some point of time it jumps to 2 amperes here, and it will goes to 0 amperes from here. It goes to, so the current waveform will be like this. Okay, it is a function of time. As the time changes, this is time vs current. And now I'm going to take the voltage across the capacitor. So here you can observe again, initially the voltage is, let's assume it is 0 and 2. Initially it is 0, and the voltage across the capacitor now increased to 2 amperes. As it is charging, the electrons are coming from here to here, the voltage is increasing, so it comes to 2 amperes. Let's put it here, 2 volts, I'm sorry, and again it goes to 5 volts, and it goes to 9 volts. That is okay, sorry guys, it goes to 5 volts and it goes to 9 volts, right? 9 volts. So this is the voltage graph of the, this is the voltage across the capacitor. Okay, this is VC and this is current I in the circuit. Okay, so now you can observe this part. When the capacitor, this is voltage across the capacitor, when the capacitor is charged to source voltage, that is 9 volts, the current will become 0. This is 0, the current is 0, but the voltage across the capacitor remains 9 volts. This part, this is nothing but the steady state part, and here is the place, or here is the time where you can say, or when you can say the capacitor blocks DC. When it is fully charged, it blocks DC here. But this phase is nothing but the transient phase of the capacitor. So if you want to see the full potential of this kind of capacitor problems, you will find out only in transient analysis of network theory. Okay, transient part is, it's very intriguing, right? If you are passionate about this, then go learn the transient. Okay, so this phase you can observe here. So one more thing is that this 9 volts, when it is when this VC is equal to 9 volts over here, you can see there will be no current. Vc is 9 volts, there will be no current, the current is 0 in the circuit, and this will behave as an open circuit. Okay, so you can observe here, when these are two 9 volts, there will be no current. There will be no current means we can say there is open circuit. In this case, that is voltage across this will be 0. Even though there is voltage across this 0, you can apply the KVL, that is 9 minus 9 is equal to 0. Okay, the KVL always satisfies at any point of time. If you take at any point of time, you have to freeze that time, then you observe the voltages across this and this capacitor, you will find the KVL always satisfies. Okay, I hope you are clear about this. One more thing, guys. Yeah, so I hope you can understand. I mean, you have understood the concept of current, the rate of flow of current. Here there will be no need for the closed circuit, because here it is open circuit. Because there is no path for the electrons from here to here, they cannot jump over, but they are flowing from this plate to this plate. This point, this process where they move is called the current. The rate of change of movement, or the rate of change of the negative charges, is current, even though there is no path, there is no closed path. This you have to observe. Okay, as I mentioned earlier, I am going to show you the what is this, the practical example. Keep up with me. So guys, this is the charging circuit that we discussed about. You can see a resistor connected in series with a capacitor, and it is in series with a LED. So when it charges, the electrons flow from this battery, and they will push to the other side of this other plate of the capacitor, and in the process the initial current will be high, and we have observed the calculation also. And when the capacitor reaches to the source voltage, which is 9 volts I am taking here, so the current decreases. As a result, the bulb will also fade away. Initially there will be high current, then the bulb glows brightly. Later the current decreases, the bulb glows, I mean it will reduce its brightness according to the current, as the voltage is piling up in the capacitor towards the source voltage. So when the capacitor is fully charged, that means there will be no potential difference between this capacitor and the source voltage, that which is a battery here. So there will be no current, and the bulb will also eventually puts out. So this is the thing you have to observe. So I'm going to connect it. So carefully observe the brightness of the bulb. It will changes from high brightness to low brightness, and high level to low level. That is the thing you have to observe. So I'm going to put out the light and connect it. So observe that. Just a second, guys. I'm doing nothing. Okay, observe that. The capacitor is charging, the bulb is getting darker and darker and darker, because the capacitor is piling up the voltage across itself towards the source voltage. So the current decreases, and the voltage, I mean the brightness decreases. You can observe it here. Okay, and one more thing, I don't have that much of editing skills or any other things to fool you, or something. You can try it at your home. So this is the beauty of the capacitor charging and discharging. So guys, maybe that's it is still glowing, so that may be some leakage current in the capacitor. So this is the thing, guys. Thank you for watching. Please do like and subscribe if you like this video. Okay, and give me your valuable suggestions. That's it. See you guys. Take care.